So today we will go over Apache Cassandra. We will try to understand the workings of Apache Cassandra and possibly learn why it is used and where it is used and why it is better than the others. That's there. Okay, so let's begin. So what is Apache Cassandra? Apache Cassandra is a NoSQL database which is designed for high write and read throughputs. It was created at Facebook and it has features from DynamoDB and Bigtable. So in my company, we kind of use Apache Cassandra and we store protobufs. So it can even support protobufs. The key features of Cassandra here are it is highly available because it has it works over a bunch of nodes and it's not like just one machine that it talks to, so that is highly available. Okay, some special feature about its data modeling is that usually when you're kind of designing a database, right, you kind of think, okay, I have my names, I have my like addresses of people, whatever, and then you kind of design like an entity relationship, and then that's how you kind of translate that to like tables. But actually in Apache Cassandra, you kind of model the table according to the queries you're running. So the queries actually drive how we are storing the data, not the app requirements as such. And why is that so? Because in Apache Cassandra, you cannot join tables. So there are no table joins. You can't say that, okay, join X with Y. You can't do that in Apache Cassandra. You have to get everything from one table. Like, so if you want to retrieve something, you have to get it from one table. You can't do joins over multiple tables. So now let's talk about the indexing and how it stores the data. So Apache Cassandra has wide column store. Okay, so that means that the rows can have n number of columns and n data types. So they're not constrained on, okay, you can have like 5 columns, or like you can only have strings that are the data types of the columns. You can have anything. And when you're storing data, it kind of looks like this. First thing is you have a primary key when you're storing data, and then you could have one or more partition key and 0 or more clustering key. So if you kind of have a hierarchy here, the first hierarchy is primary key, then partitioning key, and then clustering key. So if you look at this example over here that I have set up, I have this table which has an ID, app name, environment, city, primary key, and the primary key is based on app name and environment, and the city is the clustering key. So if you can see, if I have these brackets which kind of instill that the first part is the primary key or the partition key, and this is the clustering key. So what is this? So this is the central node or the controller. Okay, and when it gets this table command, you see app and environment, and this is what I have. So the app, this is the app, first one is app, environment, and this is city, right? So first I have 3 nodes here, node 1, node 2, node 3. So the app 1, app 2, app 3 with their different environments are distributed across the different nodes. So all the data that comes within this will go into app node 1, and then if I had more cities like x1, x2, x3, over here they will be lined up as x2, x1, x2, x3. They'll be sorted here. So that's how the storage works in Cassandra. So in the inner workings, if I had to think about, okay, I understand that the data for this app 1, app 2, app 1 p environment is like on this node, and then within that I have cities, and they are sorted based on lexicographically. right? So how is it storing it? So Cassandra inside itself uses LSM tree, okay, and SS tables. So how does that work? Let's get a brief overview. So tree is nothing but a balanced binary search tree that is in memory, okay? And an SS table is just this tree translated in order to a table that is sorted. So for this example, if I when this table is written into a SS table, it looks something like this. It is sorted, okay, and it has everything. And there is this collection step in which whenever this memory is being reached of the binary search tree, the B tree is written to a table. And if you can see something over here is Matt is here and Matt is here. So Matt was first 60 and then Matt became 90. So how does this work is when you insert it to the binary search tree, right? So how does this work? When you have an insert, you insert it to binary search tree. And when the binary search tree is full, it goes to the SSN table, which is a sorted list. And then whenever you retrieve, let's make some space. So when you retrieve, you look into BST. If it is not there, then you look into latest SSN table. Example, you can see Sheila was removed, okay? So from 99, there's something known as tombstone, in which it signifies it has been deleted, okay? So when you're reading this and you want to look at Matt, right? So you will read from binary search tree. If it is not there, you look at the SSN table, which is sorted. So you can do B search over here to get a faster look. So we already talked about how the create table command, right? So that is called primary key, partitioning key, and then the cluster key. In Cassandra uses consistent hashing, which puts data in such a way that new nodes and that are added and removed have minimal rebalancing. And for replication, all the writes are sent to all replicas for a given partition. So if the client is suppose writing to the controller, I'm saying like, okay, write this. The client is actually writing like to X number of nodes, okay? So what are the possible drawbacks? There could be like conflicts, like if this client is another client too, which is writing again at the same key, then there'll be a clash, right? So how do we handle this? They say last write is the true write, okay? And then how do we know that we have updated? So you could kind of set a setting in which you say either update me that okay, I have updated everything if n number of nodes have accepted the thing, or all of them. So it is very configurable, okay? So within itself, there's anti-entropy. So you can't have like this node has say x equals to 3, x equals to 1, x equals to 3, x equals to 3. So if this is a stale value, the Cassandra controller kind of checks that okay, what is the value in most of the nodes, and then you update it or you correct yourself. So because the data is being stored in a bunch of replicas, the faults are detected through gossip protocol. Because the data, so now it is fault tolerant. So there could be like this one also has some replica, right, on the node. So it is fault tolerant. So if n1 dies or this n3 dies, the controller will see that okay, let's say over here we have n3, so we can send this data back from here, okay? And faults are detected to gossip protocols, which are nothing but like the controller um, asking the nodes for like a heartbeat and okay, are you responding? If not,